Hey there! Here we are on lesson 27, and we are looking at this time the same process where we are dividing with fractions. However, this one's all word problems, so that you want to try and picture what's happening. It kind of makes it easier as far as thinking about the units that you're working with. So in this case, we're starting with 4 pizzas, and then we're going to cut those pizzas into 8s, and we want to see how many slices there are all together. And it says draw a picture, and I'm going to do this picture 2 different ways. I'm going to start with one of them. This is going to be a tape diagram, and it's long and skinny because this needs to kind of serve as 4 actual pizzas. So I'm going to use red for, like, pepperoni. So that idea. And so if each one of these is going to be broken into 8 pieces each, so each one is 8 pieces each. Each one's 8 pieces each. Now another way to look at it is if we say here's 4 pizzas. 1, 2, 3, 4 each. And then we go through and we say, okay, I'm just going to make this one into 8 pieces. 8 pieces here, 8 pieces here, because we're going circles because they're pizzas, right? How many pieces are there total? Well, we can say then that if there's 8 times 4, 8 pieces times 4 pizzas altogether, it's going to get us 32 pieces. And so what did we just do? We took 4 and we divided it into 1/8. So how many 1/8 can you fit into 4 whole pizzas? So when we go to divide, remember that standard idea, this we're going to turn into an improper fraction. 4 over 1 is the same as 4. We are going to be multiplying. We're going to flip this one also because we are trading up. And that's how we got 32. That's why it matches. Now let's cruise on down and we're going to take a look at this one. A pitcher of water. Here's your pitcher. Right here. If this is a whole liter, we're looking at a pitcher that holds 1/4 of a liter. Here's our pitcher right here. This whole thing is a liter, but we're only dealing with 1/4 of it. This is 1/4 of a whole liter. And now what we're going to do, we've got some friends over, and so we're going to serve water to our friends, and we have 5 friends. So each one of these is a glass of water. Each one is a glass of water. What if we wanted to say how many liters or what fraction of a liter is each of our friends getting? We have to then give attention to the rest of the non-existent amount, right? Because this is all we have, but we have to think about how much of a whole liter would all of this be. So if each one of these was 1/4 of a liter that was broken into 5 equal pieces, so this is 5 pieces here, and here's the imaginary ones. Here's 5 more glasses, 5 more glasses, 5 more glasses. We would get a total of 20 glasses out of the whole thing, right? And now we're looking at how much is in this one. How much of a whole liter then is this glass right here? It's 1 piece out of 20. So it's 1/20 of a liter. Does that make sense? So kind of here's what we've done is we have said 1/4, and we divided that 1/4 by 5 over 1. And remember, standard algorithm, the parent style, 1/4 stays the same because you're still looking at 1/4 of a liter. And what are we doing? We are breaking it into how many pieces? 5 pieces. So we know that 4 times 5 would get us 20 altogether if we were dealing with a whole liter. So 1/20th. That's how that works. The next one I'm going to do is kind of complicated in terms of changing what we're using. If we have 1/20th of a liter, remember how we did that before. We said 1/20th times 1 whole liter. And now, in this case, we want to move to milliliters. So we keep our 1/20th, and then we have to convert 1 liter into milliliters. How many milliliters were in a liter? You remember? There was 1,000 of them. And so when we go to multiply this, we have 1 times 1,000 and 20 times 1. We end up with 1,000 over 20. And when you go to simplify this, you could think about it as, I know that 20 goes into 100 5 times. 20 doesn't go into 0 at all. So it ends up 50 milliliters altogether is how much each glass held. Now let's take a look at this one. We have Drew has 4 pieces of rope and they're 1 meter long each. He cuts each rope into fifths. So how many fifths will he have after cutting all those ropes? So if he's got 4 pieces that are 1 meter each, if it's 1 meter each, so there's 4 meters here altogether, right? 4 meters altogether. Here's those 4 ropes. Each one is 1 meter, and he cuts each one of those into fifths. So let's get a new color. I'll go with this one. So 4 lines gets us fifths. And so this one now, we're looking at 1 meter that's been broken into 5 pieces each, right? How many fifths then are there altogether? So here's 5, 5, 5, 5. And so we know that 5 times 4 is going to be 20. So there's 20 pieces altogether. How many fifths will he have? After cutting all of those ropes, he's going to have 20 fifths. Actually, that doesn't say 20 fifths, does it? This would. 20 fifths. That would do it. How long will each of the fifths be in centimeters then? So if each one of these is a meter, we also too then know that that's 100 centimeters. And so we want to think about, okay, so this is 5 out of 100 centimeters. So this one right here, we've broken this 100 centimeters divided by, we need 1/5 of that. 1/5. So what's happening there? We're going to go 100 times 5. So let's see, how long will each of the fifths be in centimeters? So that wouldn't be true if we flip this, right? Would it? Because then we're going to end up 5 times 100 and it would end up being 500 centimeters. We know that's not true because that would be wrong. So that can't be it. How long will each of the fifths be in centimeters? So this one right here, if you go 5, and we're saying 100 centimeters divided by 5. You know 5 goes into 10 twice, and into 0 times. So each one of those fifths would be 20 centimeters. Because if this is 20, 40, 60, 80, 100. So that would be our meter. So that's how that is. So let's take a look at the homework. One word problem. Kevin divides 3 pieces of paper into fourths. How many fourths does he then have? And so you could do that the way we did, remember with the pizzas? We started with saying, oh, it's a big long one and there's 4 in it. You could say big long one and it's like 3 pieces of paper all next to each other. So do number 1. And that's it. And it does ask you to draw a picture to support your response. Thanks.